Yes, guys. Today we'll discuss conic sections. As I mentioned in the last class, we'll come across, any engineer will come across different various engineering curves, like one of them is conic sections. Conic sections are namely, why this? What is the name conic sections? The name itself is revealing that a right circular cone, when it is cut by a section plane in various orientation, in different orientations, we will obtain various conic sections. Conic sections are also called conic curves, and conics also we can call them as like that, conic sections, conic curves, or conics. So as I said, when a right circular cone is cut by a section plane, we obtain the conic section. A part of the cone is removed, and then we'll able to see the new face, and its shape would be called conic section. And let's see this. So this is a cone. When we look from the front, cone looks like that. It is resting on its base. That is, axis is vertical, and always when right circular cone is mentioned, it's that is the cone, and it is cut like this. That is, section plane is making certain inclination with the ground. Let's say, so here you can say it as it is making certain inclination with the axis, or it is making certain inclination with the base, right? So now let us see, here it is not there, let's say, but just think of this is, it is apex angle. This angle for a particular cone, it is called apex angle. Apex angle is constant with reference to, in relation to, say, this is a particular cone, we call that as, let's denote 2 theta. And this is the section plane, and this angle, let's say alpha, is the angle between the axis and the section plane. So there is a relation between the theta and alpha. So theta means what? It is half of the apex angle. And what is alpha? Alpha is the angle between the axis of the cone and the section plane with which we cut that cone. So there is a relation between theta and alpha. Theta is constant, half of the apex angle. But whereas alpha we can change, because depending upon the section plane, it is cut like this or it is cut. Let's see that. So it is cut like this. That here it is. Alpha is greater than theta. Here alpha is greater than theta. This angle is greater than this angle. This is the angle, half of the apex angle. This is theta, the whole angle is 2 theta. Whole angle is 2 theta. Half of the apex angle, it is just theta. So theta is less than alpha. We have taken the section plane in such a manner, we have fixed the orientation of the section plane in such a manner that alpha is greater than theta, but alpha is not equal to 90 degrees. 90 degrees means it will be like this. That is 90 degrees means alpha is the angle between the axis and the section plane. So alpha is 90 degrees means different, but here alpha is greater than theta, but not less than 90 degrees. Then we'll get, that is a part of the upper part. This part is removed, and this is the new shape which is appearing on the remaining solid, is called conic section, and namely it is ellipse. So ellipse is obtained when the alpha is greater than theta, but less than 90 degrees. What happens if it is 90 degrees? Obviously, easily you can get it. 90 degrees means it is like this, horizontal or parallel to the base. So obviously it would be a circle. It would be a circle. So circle also a conic section, but we know how to draw a circle. We have a compass, and in order to draw a circle, we need a center and a specific radius for it. With that, we can, by using the compass, we can get the circle. We know it from the school days, we have been doing that. But whereas ellipse, the mathematics of ellipse we have discussed, we might have discussed in intermediate, in the even 10th class also, some of the schools. but we did not discuss about the construction of these conic, specific conics. And one of them is ellipse. Ellipse, already we have cleared it. That alpha is greater than theta of half of the apex angle, but it is less than 90 degrees. If it is 90 degrees, it will be a circle. And let us go for another one now. So now this is, here it is, alpha is less than theta. It is very clear. Alpha is less than theta. Alpha is less than theta. Let's say here it is, no, I think it is alpha is, yeah, section plane parallel to the one of the generators. So you can write infinite number of generators on the lateral face of a cone. What is a generator for cone? Generator is a line drawn which joins the apex with any point on the circumference of the base. That is called generator. So you can find infinite number of points on the circumference of the circle. So a straight line which joins the point on the circumference to the apex is called generator. So here the section plane, we have changed the orientation. This section plane is parallel to the generator. That means alpha, this is alpha. Alpha, what is alpha? Alpha is the angle between the section plane and the axis. This is alpha. Alpha we have changed. But this is half of the apex angle. Theta is constant. So we have changed alpha, whereas alpha is equal to theta. Then we'll get the parabola. If this part is removed, so this is parabola. So this is another type of conic sections. And let us go to next one. So here this is how it is. Here if you see this clearly, section plane parallel to axis it is said. Before that we have to discuss another thing actually. Whereas alpha is here, alpha is greater than theta in the ellipse. In the parabola, alpha is equal to theta, but now it is further reduced. The alpha is lesser than theta. Here it is not given like that. That figure is not given. So alpha is lesser than theta. A part of that solid cone is removed. Then there appears a new shape that is called hyperbola. So alpha is less than theta. Then we'll get the hyperbola. If alpha is reduced further to 0, that means the section plane is parallel to axis as seen in the figure. Then it is called a specific typical hyperbola, which is called rectangular hyperbola. So we have discussed ellipse, parabola, and hyperbola, and out of that again a typical hyperbola, that is rectangular hyperbola. All these three we didn't discuss in the previous classes. Therefore, we will go for this. And another section also is there. We can obtain another section. So what is that? Let's see the next slide, if it is there or not. We shall see. No, let's say it is not there. Let us go back again. Oh, sorry. Let us go back. So here, as I said, circle is not there. Which also is the conic section. Another last one, that also is not there, because that also we know how to construct it. That means if this cone is split into two equal halves like this, suppose say the section plane, it is parallel, no? It is set parallel, but it is at certain distance. That's why we are getting rectangular hyperbola. But with the same 0, it is not parallel but coinciding with axis. That means the cone is divided or split into two exact halves. There appears, it looks like this only. Obviously, if this part is removed, let's say, section plane is coinciding with the axis and this part is removed, then when you look from this side, it looks like this only. That means an isosceles triangle appears. So we know how to construct circle and we know how to construct isosceles triangle. The other three being ellipse, parabola, and hyperbola, we should discuss that construction part. So that is the required essence of this topic, conic sections, construction of the ellipse, parabola, and hyperbola. That's a typical hyperbola, that is rectangular hyperbola. Okay, are you ready? Okay, let's go for this. Here if you see, for all these conic sections, that is namely ellipse, parabola, hyperbola to be constructed, there is a definition which is applicable to all the three conic sections. That's why it is called general method. Okay, we will be following this definition and we will be getting this conic section. So that's why it is general to all, therefore we call it as general method. So let us what exactly is the definition. So here is there. What is this? These are the loci of points moving in a plane such that the ratio of its distances from a fixed point and a fixed line always remain constant. Again, it is called, the ratio is called. So here let's see a fixed point and a fixed line. So that means there are two entities here clearly. And another one is moving in such a way, moving point, loci of points moving. So a point is moving in such a way in relation to this fixed point and fixed line. So when we say fixed point and fixed line, there must be a fixed distance between them. Fixed point and fixed line, there must, so that should be given to us. One is that. And the other important thing is that the ratio is always constant. So while finding these points or the various positions of the moving point, because loci of that means after finding those various positions, we'll be connecting them to get that our point, right? So the ratio is very important. What is that ratio? It is the ratio of the moving point's distance from the fixed point to its distance from the fixed straight line. So that ratio should be maintained constant while finding these points or while finding the various positions of the moving point. So this ratio is called eccentricity. Always do remember, it is ratio. There is numerator and the denominator. Numerator part indicates it is, or it refers to the distance of the moving point from the fixed point. So don't get confused. Every time there is every possibility. When data is given, sometimes this will be kept first. So then we'll get into confusion. So always keep that in mind. Distance from the fixed point should be in the numerator and distance from the fixed line should be in the denominator. So that ratio is called eccentricity. So while we are using this eccentricity, that's why this method is called that method. We are going to follow this method is this definition is called eccentricity method also. So the method is called general method or eccentricity. And if eccentricity, so there are, as I said, it is not only one conic section. There are three ellipses, three conic sections. So if the eccentricity value is less than 1, then we'll be getting ellipse. If we connect all the points, moving points, positions, various moving points, positions, we'll get ellipse if E is less than 1. If E equal to 1, we'll definitely get parabola only. If E is greater than 1, then we'll get hyperbola. So these things to be kept in mind. So that means in order to follow this definition, we need two parameters. One parameter is the distance between the fixed point and the fixed line. And here one more thing I have to add. So I missed it now, so I'll add. So what is that? Fixed point is called focus, another term. Fixed line is called directrix. So fixed point focus, fixed line directrix. So there must be some distance, as I said, between those two entities. So that should be given to us. The second one is in order to get a specific conic section, ellipse, parabola, hyperbola, definitely we need to be given this E value. So these two parameters, one is distance between the focus and directrix, and the second one is E value. Those two should be given. Then we will be getting, just by following a general method, some certain sequence of construction steps will be there. So we'll be getting that now. So that is one thing. So let us stop here.